All right, good morning, everybody. Welcome to the new unit, new week. We have a couple more days until we get to our holiday break. I was going to wait and start the new unit when we get back, but I'm going to start it today. The next unit that we're going to talk about is going to be called energy. Normally, we would have went into gravitation, but that is not easily going to be taught over the internet. So I'm going to wait to see if we have the opportunity to go back to school to do that unit. The next unit is going to be called Work and Energy. And energy allows things to occur in the natural universe, changes to occur. Nothing happens without some sort of exchange in energy being consumed or transferred, and so on. The unit starts with the concept of what we call work. Work is done to a system by uh, pushing on something with a force. If you see these guys in the picture here, they are pushing on the plane with a force, and that's because the plane will move a distance, okay? Because we push on the aircraft with a force and it moves over a distance, we're going to define that the work or the energy that it takes to move it uh, by doing work is equal to force times distance. It's important to acknowledge that both the force and the distance have to be in the same plane right there. If I want to look at the unit of this right here, force is measured in newtons and distance is measured in meters. So the unit for measuring work is going to be a newton times a meter. But the just like William Samuel Chestnut is too much for my friends to greet me with all the time. Newton times meter is also can be abbreviated, and that's going to be abbreviated with an abbreviation of. I'm sorry, hold on. A Newton times a meter is also known as joule, just like William Samuel Chestnut is known as Yobo. In order for work to occur, we need to make sure that we have both a force being used and also motion being occurring. If we push on something like the wall and it doesn't move and there's no distance moved, no work is done right there. So you can see this acrobat is standing here, okay, and they're standing still. No work is being done on that person right there. Okay. The next one we could see that if I wanted, I can look at work as a vector quantity, meaning that it has direction. If the force and the distance that it moves are in the same direction, we're going to call that positive work right there. Okay. If the force is in the opposite direction of the displacement or movement, we're going to call that negative work right there. And quite simply, the last situation that we could look at would be if the force is in the complete opposite, different direction than the motion right there, not even parallel, we're going to have zero work done right there. Another way that we could have zero work done is if there's no displacement occurring, like I said before. So, so let's wrap it up. Let's go back and look at this right here. Work is defined as force times distance. Force is measured in newtons. Distance is measured in meters. So the unit for work is a newton times a meter, which is abbreviated as a joule J. Joule is the SI unit for any type of energy. We're going to see that that unit will be applied to various types of energy, whether it's going to be work, potential energy, kinetic energy, electrical energy, elastic energy, are all measured in joules. So we saw that right there. Okay, once again, work is equal to force times distance. The unit for force times distance is a newton times a meter, which is also known as a joule. A joule is also known as its most formal name right here is a kilogram meter squared per second squared. Not to be confused with the Newton, which is a kilogram meter per second squared. This is a kilogram meter squared per second squared. It's known as a joule. It's named after James Prescott Joule, who studied energy. And the thing that he noticed was that if we were to stir a cup of water, it would increase in temperature. There are a lot of different experiments that he did, and we'll get to those later. So if we want to do our first problem right here, and we can see that it says a 24 Newton force, so that's the force, moves a distance of 10 meters. How much work is done? Notice it's positive 24. Work equals force times distance, which is equal to 24 newtons times 10 meters, gives me 240 newtons meters, or 240 joules. So this response right here is correct right there. Let's keep moving forward to the next problem here. And we can go ahead and get rid of that. Okay, so now I have a positive 24 Newton force. That's my force, but I'm moving 10 meters in the opposite direction. So this is my distance right here. Because it's the opposite direction, we have to put a negative in there. If I want to do work is equal to force times distance, that'll equal 24 newtons times negative 10 meters, which gives me negative 240 joules. First response. Now I'm going to apply a force, but the object is going to remain stationary. If it remains stationary, we can calculate the work. Work equals force times distance. So it's going to be positive 24 newtons times distance of 0 meters with no displacement. We're going to see that we will have no work occurring right there. Let's keep on moving here. How much force must be applied to an object if it gains that energy, which is the work right there, over a distance? So if work equals force times distance, then force is equal to work over distance. The work that we did is the amount of energy, which is 100 joules. I'm sorry, I almost said Newton, over 20 meters. Okay, so 100 over 20 is going to be 5, and the unit for force is going to be newtons. All right, let's keep on moving here. What distance must we go? Okay, so if work equals force times distance, distance is equal to work over force, which is equal to, okay, so we have this much force, use this much energy, which is the work right there. So we can calculate the distance. It'll be 1,600 joules over 400 newtons. That gives me an answer of 4, and the unit for distance will be meters. All right, let's keep going here. Okay, so some of these problems we're going to see that they will be giving us speed and time and force right there. The next formula that we need to look at will be this right here. Work is equal to force times distance. And we should remember from kinematics that distance is equal to velocity times time. So work will be equal to force times velocity times time for these here. So that's the next formula here. So if we want to calculate the work that's done, I can apply a force of 100 newtons, which makes and the velocity, was 3. Time was equal to 100. 100 times 100 is 10,000. Times 3 is 30,000. So the work will be 30,000 joules right there. Keep on going here. Let's keep this. Oh, what a wonderful day for a sleigh ride. Hope everybody's having a nice day. Once again, in this example, I'm going to be doing work is equal to FVT because they're giving me a V, an F, and a T. So it's going to be equal to 350 multiplied by V, which is 1.2, which is multiplied by the time, which is 100. If I get out my trusty calculator here, let's take a look at this here. 350 times 1.2 times 100 is equal to 42,000. Okay, 42,000 joules because we're studying or solving for energy. Let's keep on going here. See what this question is about right there. We're going to skip number 11, skip number 12, and I think that that's what we're going to leave it with today. That's pretty good. That's enough right there. So let's go back and review what we learned today. Today's lesson was on the start of the energy unit here. If we want to look at work, work was defined as the amount of energy it takes for something to happen. Work is equal to force times distance. The unit for work is going to be a Newton times a meter, which is abbreviated as a joule right there. It's important to remember that if the work and the displacement are in the same direction, that's called positive work. If the force is opposite of the displacement, that'll be negative work. And if the force is not even parallel, or if there is no distance, we'll have zero work done there. If we keep on going, once again, if work is equal to force times distance, the unit was Newton times meters, which is a joule, which is also a kilogram meter per second squared. All right, I'm running out of time on my video. If you have any questions with today's lesson, you can reach out to me. I'm going to put some example problems. In addition to that, I'm going to ask you also to please enter in your attendance into Power School. I'm sorry, no, not Power School, into Teams for the day, and that way I can give everybody credit for being here. All right, thank you. Have a great day. Bye-bye.